So in this video, I'm going to go over the review questions for our second test. I may have to split this into multiple videos depending on the length. So this is the first of what may be multiple videos. So we're going to begin by looking at question 1, where we want to solve the following equations, and we'll do that on a separate sheet. So here I've rewritten our equations, part A and part B. So in part A, we want to solve the equation 2/3 x plus 2 equals 1/6 x plus 4. So the simplest way probably to solve this equation is to, first of all, rewrite the equation without fractions. And so we can do that by multiplying both sides by the least common denominator of all the fractions. So if you look at 2/3 and 1/6, which is really the only two fractions in our equation, the least common denominator for that is going to be 6. And the reason for that is 6 is the smallest number that can be divided by both 3 and 6. So we're going to multiply both sides of the equation by 6. So we're going to have 6 times 2/3 x plus 2. And that's going to equal 6 times 1/6 x plus 4. And then we're going to have to distribute the 6 on both sides. So 6 times 2/3 is 4. So 6 times 2/3 x is going to be 4x plus 6 times 2 is 12. That's going to equal 6 times 1/6 x. Well, 6 times 1/6 is 1. So 6 times 1/6 x is just 1x, or x, and 6 times 4 is 24. So now we can continue solving. We now have an equation that does not have any fractions in it. So I'm going to subtract x from both sides to get all of the x terms on the left-hand side. 4x minus x will be 3x. We still have plus 12. X minus x goes away, so that equals just the 24. Subtract 12 from both sides. So on the left-hand side, we're going to have 3x. The 12's go away. And on the right-hand side, 24 minus 12 is 12. And finally, we divide both sides by 3. So x equals 12 divided by 3, which is 4. So the solution to our equation is 4. In part B, we could multiply both sides of the equation by 10 to remove the decimal points, but it's really not any, it doesn't really make solving the equation any simpler, so I'm going to just work with the decimal points. So I'm going to subtract 3.5x from both sides of the equation. 0.3x minus 3.5x will be negative 3.2x. So we have that minus 2 equals the 3.5x minus 3.5x goes away on the right-hand side, so that equals negative 0.4. I'm going to add 2 to both sides. So I'm going to get on the left-hand side negative 3.2x. The minus 2 plus 2 goes away. On the right-hand side, negative 0.4 plus 2 is going to be positive 1.6. And so we can divide both sides by negative 3.2. And so on the left-hand side, x is going to equal 1.6 divided by negative 3.2 is going to be negative 0.5, or negative 1/2. So the solution to our equation is x equals negative 0.5, or again you could say x equals a negative 1/2. Now let's look at the second question. In our second question, we want to solve a equals p times the quantity 1 plus RT for the variable r. So again, we'll do that on a separate sheet. So I've written our equation. We're wanting to solve for r, which means I need to get r by itself on one side of the equal sign. Well, right now r is inside the grouping symbols with the 1 plus and RT. So we're going to have to begin by distributing the P. So A is going to equal P times 1, which is just P, plus P times RT, which is PRT. So again, I want to get the R by itself, so I'm going to subtract P from both sides. And so if we do that, we're going to get A minus P on the left-hand side. P minus P goes away, and so that's going to equal just the PRT. So to get the R by itself, I'm going to divide both sides of the equation by P and T. So on the right-hand side, the P and the T will cancel, leaving just the R. And on the left-hand side, we have A minus P over PT. So R is equal to A minus P over PT. So there is our equation solved for R. Let's look at question 3. Question 3, Daryl works at a warehouse job where he is paid $5 per hour up to 40 hours per week. If he works over 40 hours, he is paid twice his usual wage. Assume that he always works at least 40 hours per week. In part A, we want to model the situation with the linear equation. In part B, we want to know how much he would earn if he works 46 hours in a given week. Okay? So we'll work that on a separate sheet here. So we have number 3. Okay, we know that he gets paid $5 per hour for the first 40 hours, and then he gets paid double that or twice that if he works over 40 hours. Okay, so for the first 40 hours, in order to figure out his income, we'll say S, that is going to equal $5 per hour for the first 40 hours. Okay, so he's going to make 5 times 40 for the first 40 hours. And then he's going to get twice $5 an hour. So twice $5 an hour would be $10 an hour. But he only gets that for the amount he works over 40. So if H is the number of hours that he works, then he's going to get $10 per hour for H minus 40 hours. So in other words, say he works, say, 42 hours, then he would get $5 an hour for the first 40 hours, and then he would get $10 an hour for the 2 that's over the 40. Okay? So this would be our answer to part A. This is our model. Okay? Now we can clean that up a little bit. So for example, 5 times 40 is 200. So we might write that as 200 times, 200 plus 10 times the quantity x minus 40. So we could write this, or if we wanted, we could actually continue and clean that up a little bit more. This, as far as I'm concerned, is a perfectly fine answer. Again, if you wanted to, though, we could distribute the 10 here. So we could say that we're going to have 200 plus 10 times h would be 10h, minus 10 times 40 would be 400. And so 200 minus 400 would be minus 200, so we'll have 10h minus 200. So we could either say S equals 200 plus 10 times the quantity h minus 40, that's fine, or we could say S equals 10h minus 200, that's fine as well. Now in part B, we want to know what would Daryl make if he worked 46 hours in a week. So if H equals 46 hours, then how much would he earn? Okay, so we can plug that 46 in for H in either one of these equations. Let's use this one. So S would equal 200 plus 10 times 46 minus 40. And then we just have to simplify. Well, 46 minus 40 is 6. So we're going to have 10 times 6. So multiplying 10 times 6 is 60. So 200 plus 60. And so that would be 260. So if Daryl worked 46 hours, he would make $260. Now, just for the sake of it, we could have also have substituted the 6 for h in the second equation that I have here, so we would get the same answer. So we'd have 10 times 46 minus 200. 10 times 46 would be 460 minus 200, and that would still be 260. So let's look at question number 4. So in question number 4, we want to graph the equation 3x plus 5y equals 20 by plotting the intercepts and drawing a line through them. Okay, so again, let's do that on a separate sheet. So here I've written our equation that we want to graph, and we want to graph this by finding the intercepts. So remember, to find the x-intercept, we let y equal 0 and solve for x. So if I let y equal 0, then I'm going to have 3x plus 5 times 0 equals 20. Well, 5 times 0 is just 0. So on the left-hand side, we're going to have just 3x. So we have 3x equals 20. And so if we divide by 3, x equals 20 thirds. That's not going to divide evenly, but if we were to divide 20 by 3, that goes 6 times with the remainder of 2. So this would be 6 2/3. Okay? Now, in algebra, we generally don't use mixed numbers. So we would say the x-intercept is the point 20 thirds 0, or that's really about 6 2/3 0. Now to find the y-intercept, we let x equal 0, and we solve for y. So letting x equal 0, we're going to have 3 times 0 plus 5y equals 20. 3 times 0 is 0, so we have 5y equals 20. And so divide both sides by 5, y is going to equal 4. So the point 0, 4 is our y-intercept. So if we're going to graph that, here's our x-axis, here's our y-axis, okay? So if here is 1, 2, 3, 4, 5, 6, 7, 8, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, 1, 2, 3, 4, 5, 6, 7, 8 on the y-axis, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8 on the y-axis. Okay, so I'm going to just label, there's 8, there's 8, there's negative 8, there's negative 8. So if I find the point 20 thirds 0, so again 20 thirds is really about 6 2/3, so 1, 2, 3, 4, 5, 6, and 2/3 would be there, okay? And the y-intercept 0, 4, that would be there. And so if I bring in my ruler here, I can connect those 2 points. So this would be the graph of our line. Now let's look at number 5. Number 5, we want to find the slope of the line passing through the points 2, 5 and 6, 8. So again, we'll do that on a separate sheet. I've written down the 2 points. Now remember, our slope formula is y2 minus y1 over x2 minus x1, where x1, y1 is one of the points, and x2, y2 is the other point. So in other words, if I let x1 be 2 and y1 be 5, then x2 is 6 and y2 is 8. And I'm just going to substitute those into my formula and simplify. So y2 is 8 minus y1 is 5 over x2 is 6 minus x1 is 2. 8 minus 5 is 3. 6 minus 2 is 4. And so we have the fraction 3/4, which will not simplify. So the slope of the line that goes through the point 2, 5, and 6, 8 is 3/4. Let's look at number 6. So in number 6, we want to match the line in the diagram with the given information regarding its slope. Assume that the scale on both axes is the same. So we're supposed to match our 4 lines shown here, A, B, C, D, with the description. Okay? So in the first part, we have a positive slope which is less than 1. Okay? So a positive slope less than 1. That means it could be something like 1/2 or something like that. Line 2, negative slope between -1 and 0. So again, this is a negative slope. It's between -1 and 0, so that could be maybe something like -1/2. Line 3, the slope does not exist. And line 4, the slope is greater than 1. Well, let's take a look. Let's start with line 3. Line 3, if the slope does not exist, that means the slope is undefined, and that's the case when we have vertical lines. If we look at our 4 lines here, B is the only one that's vertical, so B is the line where the slope does not exist. Now, positive slope versus negative slope. Remember that a positive slope means that the graph, the line slants upward as you go from left to right. A negative slope means the line slants downward as you go from left to right. Okay? Well, if you look at our choices, only B has a negative slope. It's the only one that's going down as you move from left to right. So number 2 has to be line D. Okay? Now, lines 1 and line 4 both have positive slopes. Line 1's a positive slope and the slope's less than 1. Line 4 has a slope greater than 1, which means it's positive. So basically what that means is if the slope is greater than 1, that's going to be a pretty steep slope. If the slope is less than 1, then it's not very steep. Well, if you're looking at our remaining 2 choices, A and C, C is obviously steeper than A. So A has to be the line that has the slope less than 1, and C has to be the line that has a slope greater than 1. Okay? So that's 6. Now we need to look at number 7, but let's go ahead and do that on a separate video. So I'm going to conclude this video stopping at number 6, and we'll start with number 7 on the next video.